What we're doing here is going to look at some oxidation reduction, some redox reactions. That means transferring electrons from one place to another. One of the electrolysis experiments is electrolysis of copper sulfate solution with copper electrodes. And with that, you can see at the end of it that the copper is plated at the cathode. We see to look for evidence of dissolution of the copper electrode at the anode. And rather than try to see through a blue solution, what I have here is a solution of sodium citrate. And what we're going to do is run an electric current through this, and it's all set up to go, and we're going to take a look at what happens. And this will take a few minutes to get going. While that's happening, what I'm going to do is set up here an aluminum can. I'm going to score the inside so they don't have aluminum in contact with the beverages inside. We don't want that to happen. And so there's a lacquer finish. We scrape the lacquer finish off with the edge of a file, and then pour in copper chloride solution. If you don't have copper chloride, use copper sulfate and add sodium chloride or potassium chloride. We have the dissolution of ionic materials. When they go into solution, they dissociate into ions. So if you have copper sulfate, you have copper ions. If you add the chloride ions from something else, you will have both copper and chloride ions in solution together, and hence a copper chloride solution. So we're going to leave this sit for a few minutes and then come back to it to see what happens. And you can see here at the cathode formation of a gas. You begin to see something happening here. You can see on the anode side, copper getting a little shiny. You can see here the gas being evolved, and you can see, and look carefully, you can see a blue solution coming off, sinking to the bottom. That's copper citrate. Okay, often used as Benedict solution in sugar testing. And what you have is the copper dissolving from the blue copper citrate. You could do this with ammonia as well, except you would have the odor of an ammonia solution. So the citrate, no odor, but the blue color that you see, the citrate complex being an intense sky blue. And so the students can watch that happen. Okay. Now over here, what has happened? Well, you can see that there's leakage and the can has fallen apart. You can see that the copper chloride has reacted with the aluminum. And I'm not sure if you can see the copper here, but it has eaten right through the can, and we now have the can split. So this is known as the can rip experiment. Okay. Long enough, you can see that definitely the aluminum is going to convert to copper, and we have finely divided copper sponge there, and the solution has lost its blue color, and it is now in aluminum chloride solution. And you have to use a chloride or a bromide because the chloride and bromide can break through the protective coating of oxide coating of the aluminum. If you just leave the sulfate by itself or try the nitrate, they will not react in the same way. The chloride is necessary. Bromide will work. Don't try the iodide. It reacts with the copper solution.